Today we are going to be talking about Git and GitHub and why you would want to integrate that into your project pipelines. So let's see. So the reason or the impetus behind using Git is because it is what we call a vertical versioning system. And what this does is it allows you to have, instead of having 10 copies of a file, for instance, it has one copy of a file that's getting updated each time you are saving it, or as we'll call in Git, committing it and then pushing it to GitHub. And that one file is getting updated every time, but the whole history of the file is still going to be there and still going to be retrievable. If you want to go back and look at it, or you mess something up and you want to change something, you can just go back in time. But then you're not also ending up with 10 or 15 versions of this file, each with different dates and times and initials, and it's all one master file. This also, in the context of a lot of the work that we're doing, allows for what we call sane code collaboration. So multiple people can be working on code or on a results section, and this makes sure that the code is not, what's getting added by one person is not interfering with what another person is taking away or adding, something like that. This actually will end up creating a lot of headaches for us, and we'll see how that happens as we work on merging. But after some practice, it will get a little bit easier, and you will understand a little bit more about the idea of merging and working with others as we collaborate. What we're going to start with first, though, is collaborating with ourselves, which is a more straightforward way to introduce yourself to Git, and then we'll work on collaborating with other folks and other folks in the class towards the end of the semester. So in terms of the work that we are interested in, one thing that Git is really useful for is organizing a project repository for reproducible science. So if you're using GitHub, then you can set a repository to be either public or private, but it can organize everything in your project, allow you to work with others, and everybody is using that same version, right? Because we have this vertical versioning system. And then it's a really easy way for you to publish and get out your code materials and the things that you want to be publishing to make your science reproducible. So I'm going to show hopefully show an example here of what I have done. An example of what our code repository looks like and how this might facilitate reproducible science. So this is a GitHub repository for a paper that I have written, and this is part of what the ultimate goal of this course is going to be, is to end up with something like a paper repository that houses all of the code and all of the information and all the methods that you would need to reproduce a paper that you're writing or analyses that you're writing. So you can see here, so this is publicly available online, so anyone can look at it at any time. And you can see here in the README file a description of what it is. And this allows for reproducible, replicable analysis based on all of the code that is in this file. And it gives instructions on how to clean the data and then how to run the analyses. And this will end up leaving users with a book or a paper that looks like a document that you can read that is this paper, Patterns of Maladaptive Exercise Behavior from ages 14 to 24 in a longitudinal cohort. So from here, what I'm going to do is I'm going to actually show you the paper and what it looks like once it's formatted. So this is the formatted paper, and this is all, you can see, you can kind of click through. This is an HTML document, but it has, for instance, the sample size, some information about the sample, the measures that we use, some information about those measures, along with, you gotta go down to the results, and some figures and graphs that are embedded here. All of that so this entire paper is built using the documents in this GitHub repository. And so if you wanted to know, for instance, that graph that I had for the sample and how that was made, you could actually just go into this RMD file that is in the GitHub repository, and you can see this is the code that creates that graph, right? So I just wanted to give you a preview with this, that this is maybe one of the ultimate goals that you might have, and that I certainly have when I'm working on GitHub, is to create, for instance, a reproducible repository that my analysis can be uploaded to, and that others can take a look at if they wanted to, if they wanted to replicate a graph that I did or replicate a part of the analyses, that they could find everything that they needed here to do it, and then they don't have to come asking me like, oh, how did you do this analysis? How was this done? It's all right here, all in this GitHub repository. And then if I wanted to work with other folks on this repository, then maybe they could, I'm uploading, this is the master version of everything that's on this repository, and then they could download it, work on it a little bit themselves, and then re-upload the new master version that they have, and we'll practice that throughout class. So getting back to a little bit more about vertical versioning. So the good news about vertical versioning is you never lose a copy of your old work. There's one master, most recent version that's updated to be the newest on with each commit. So you can see here, this is a kind of example of what vertical versioning might look like conceptually. So you start with an initial commit, and then you make a change, and then you can do a couple of different things. So one thing might be that someone else is saying, oh, I'm going to take it from here and I'm going to work on one part of the code, number 3. Well, you work on another part of the code, number 5. And then they do a couple of things, and then they say, okay, I've done the updates that I want to do. Now I'm going to try to merge it back with yours. And then we now have one still kind of master copy that is number 6. And you can see that kind of goes on as we move here. The problems that we're going to run into are going to be these merging back and hoping that we don't have merge conflicts, or figuring out how to deal with those merge conflicts when we do. But the best remedy for that is to prevent them in the first place. And there's a couple of ways that we can do that we'll talk about as we get to it. All right, so hopefully that is, it's not straightforward, but hopefully it is starting to sink in about like what this conceptually looks like. Then, when we're talking about code collaboration, the way that this can work is, so maybe you have 2 issues that you want to fix in your code, and you're going to assign these 2 people. So Jane and Barry are going to get assigned. One's going to get assigned to the maroon bug. One's going to get assigned to this other enhancement. Then from there, they're going to fork off and each work on their own projects. And then what is going to happen is that Jane's going to say, okay, I'm done. I fixed the problem that I wanted to do, that bug. I'm going to push it back to the main repository and say, all right, I'm going to update this main repository. Then that pull request is received and reviewed, and hopefully there's no conflicts. And then if there is something that, maybe it wasn't ideal, or we needed to make another change, that can be requested by whoever is the owner of kind of the main repository. So Jane's going to go ahead and fix that, and then push it back again to that main repository, and then we're there. Notice here we've got Barry's fork is still kind of out there in the ether somewhere, so we don't have that yet. But this is an example of what the workflow of code collaboration might look like, and how that it might, when we talk about forks from the main repository and branches from the main repository, this is what we're talking about. And the idea is that eventually those are going to get merged back. Some of them might go on to be their own projects, but then if what you're intending is to merge them back into the main repository, this is how that would go. And I think this is the same, yeah, this is that same organized repository that is an example for reproducibility. So what we're going to do now is I'm going to take us on to the next bit, which is a demo, and getting started with Git and GitHub on your computer and integrating that with R and how to do that. For that, I'm going to also just note there's this Git cheat sheet in the syllabus. So I would go ahead and click on that, follow along, and we'll get started. Okay, thanks.